Hello everyone, in this video I am going to continue talking about Python classes, and in this video specifically we're going to talk about magic methods. Magic methods, also known as dunder methods, are the methods that start and end with double underscores. We're already familiar with one of them, the init method. This is the most common one for us to define in our classes. In fact, most of the time it's the only one we define for our classes. Now what makes magic methods different from normal methods is that we don't have to specifically call them in order for them to do their job. Magic methods are called by Python itself whenever we perform certain operations, such as creating objects. When we create an object, we don't specifically call the init method. We simply just use the object name. Python will call the init method itself when we do that. Now, there's a lot of magic methods, so I'll only be going over the ones you would more likely use compared to others. Let's start with the three magic methods that have to do with class creation and initialization. The first one we already know, of course, which is init. This method allows us to initialize a newly created object. It is with this method that we can set the initial values of variables that will be set in the object. And I have a example class right here. It's the config class. It's just something I made up on the fly. And as I mentioned earlier, we don't have to call the init method for this to work. All we have to do is say a equals config, and just by doing it like this, Python is going to call the init method. Now, that's not to say that we can't call the init method manually. It's just that there's only one time where it actually makes sense to do that, and that's through inheritance, which is something we'll get into in another video. The second magic method in this category is the delete method, del. This method is usually only called when the reference count of an object goes down to 0 and garbage collection kicks in, and even then, I've read that it's not guaranteed to be called. I'm not entirely sure if that's true or not. Now, I'm only mentioning this method to show it exists, but I will give a basic demonstration of it in action. Most of the time, if at all, you wouldn't be really touching this method at all. I personally have never even had to override this method, and honestly, I wouldn't know how to do so properly. The way I'm going to demonstrate it to you is probably not a good way to use it. I'm not saying there isn't a reason to do so, it's just in general, it's very unlikely you will ever find yourself in a situation where you would have to. So, just a real quick demonstration of it. I have created a del magic method, and all it does is just print out the message del was used. And I'm also going to demonstrate like when it's going to be called. So I'm going to create a second reference to the object stored in A. Then I'm going to create a Then I am going to have a message print out, deleting A. Then we're going to delete A. Then I'm going to write end of program. Now, like I said before, del is only really called when garbage collection occurs, when the reference count for an object hits 0. It's not going to be called every time we call the delete keyword here. It would only be called once the reference count for our config object fully hits 0. So the only time we should see this message is after the end of program, because once this final line here executes, the Python garbage collection will kick in, and then that's when we'll see this message print out. So I'm going to run the program, deleting A, end of program, and then the message from our del function was just called. While there may be some use cases for this function, you would rarely ever use it. You honestly have a way higher chance of utilizing the third magic method in this category, new. When we create an object, new is called before init, and is actually the one responsible for creating the instance of the object. New is a static method that belongs to the class itself, so its definition will be a little bit different from the other methods in a class. There are a few use cases where we would actually use the new method, and I think a pretty good, not to mention simple example to use is a singleton class example. So a singleton class is a class where there can only ever be one object instance of that class. Attempting to create new object instances of a singleton class after the first object has already been made usually results in that first object just being returned. Sometimes it will also result in an error, but usually it's the first thing. It usually just returns the originally created object. So here I have a class for config. It's got one class variable, instance, and right now it's set to none. But once we create our first object of config, that will no longer be the case. And that's because we override the new method here, and what it does is it's going to check to see if instance is none. And if it is, then it's going to store the object for config into it. And then regardless of whether or not it was able to make a new object, it's going to return the object that's stored in an instance. At which point Python will then call the init method, which will allow us to initialize the variables for that object. Now, just to do a quick breakdown of some of the stuff that's in the new method. So we've got the args and the KW args. Really, those are just placeholders for this example. Unless you're writing a new method that will actually act upon these variables, you typically don't have to do anything to them. You just have to put them there because in our init method, it actually takes some parameters. So if we left new without any parameters except for class, we would get an error because it will say, oh, we're not expecting anything. Why would you pass anything in? So if the object is going to have arguments, then they both have to have arguments. And this is a very simplistic, generic way to do it. However, you could technically take the same parameter names here and put them up here and it would still be fine. Because either way, we're not actually touching them in the new method, at the very least not in this example. And then here, config instance is checking to see if it's none. If it is, which it will be the first time, then it will do this bit here. Now, we'll get more into super when we talk about inheritance. I don't want to get too much into this part here because it's kind of a separate topic. We'll get into it in the next video where I start talking about inheritance because that's where we would most often use super. But we would use it here as well when we're doing this. And then we call our init and we initialize everything. And then down here we have our actual active example here. So we create an object and store it in A, and we pass in this stuff. And then I'm going to print out the information for the A object. Then down here we're going to create B, and it's going to print out all the stuff for B. Now I'm going to do 2 example runs of this, because even though this is an example for the new method, I do kind of want to show you something that has to do with the singleton class, and it'd be quick and easy. So the first one, I'll go ahead and tell you what's going to happen, and then we'll run it. Basically, once we create the A object and print everything out, we should see all this stuff print out. When we create B, we will see the message here for the singleton instance saying that it already exists and everything. But when we print out all the stuff for B, it's going to print out this stuff, not the stuff from A. And I'll explain why in a bit. Actually, one more thing I want to do. I just thought of this. We're going to print out the IDs of the objects at the end just to show that it's the exact same object. It's not going to be 2 different objects like it normally would be when we create 2 objects. So we're going to go ahead and run it. So we got our A object, logs, true, more settings is yes. Then we create B and it prints out the message, oh, the singleton instance already exists. And then it prints out the information for B. And as I mentioned, the values have in fact changed, and I'll explain why in a bit. And then we print out the IDs for the objects, and as you can see, the IDs are exactly the same. It's still the exact same object for both A and B. So it didn't create a brand new object like it normally would. Okay, so if it gave us the warning that the object had already been made, why was it made? Well, that's because, and actually this is, now that I think about it, this actually is considered important to understand when it comes to new and init. New and init will both be called regardless of what controls you might have inside either of them. If we want to control the initialization and prevent it from overriding the settings in our config, we're going to add another class variable. We're going to say initialize equals false. And then here we'll say if config dot initialized. Actually, we should say if not initialized. And then we'll set it to true at the end. Now when we run this, as you can see, it's exactly the same because we stopped it from modifying the variable values inside the config class when we called it with B. So it still has the same values as before. And that's the new method. It's not often you would actually change or do anything with this method. So I mean, there's tons of use cases in which you would do it. So there's still plenty of opportunities to use it when you need to. It's just still not often that you would do so, but it's definitely more often than you would ever use del, which is almost none. Now let's get into some more interesting magic methods. Let's start with two very useful methods, the representation and the string magic methods, which are spelled out as REPR and STR, respectively. Both of these allow us to define string representations of our objects. String is the one you would probably most often use because it specifies what is displayed when we use functions like print or string. It is meant to provide human-readable information about our object. The representation magic method is called when the representation function is called, and is meant to be informative and unambiguous. So to demonstrate that, as well as the other magic methods we're going to go over, I've got a new class called the matrix class, and I'm keeping it simple. It's going to be a 2x2 matrix. So the first thing we're going to do is add our own string magic method. It doesn't take in any parameters, and we simply return a string. Now, there are other ways to do this, and especially to make it more understandable what's going on in this code block. As long as the end result is that you returned the string and not printed it out, then how you build your string before you return it, it's totally up to you. In this case, it's a single line. It's going to print out both rows in a format that's easily readable as a matrix. So let's create a matrix. 1, 2, 3, 4. And then print A. So we're going to run it. And it prints out our matrix just as we defined in our string magic method. Pretty cool, right? All right, now let's show the representation function. Okay, so now before I show how to define our own representation magic method, let's show what it should show by default. So print rep r a. So we have to print it out. It's not going to automatically print it on screen. It will return a result, but it won't automatically print it out. So if I run this, we get this little fancy string here. And, you know, it's not very useful. Like, yeah, it shows us an object and it's showing us what looks like a memory location, but when a developer is looking at that, that doesn't really help us out too much. So let's define our own. So this is also going to return a string. And typically, because representation is more for developers to look at, and it's supposed to be clear and unambiguous on what it is, we're going to do something like this. And this is not something I've come up with. This is not something original to me. This is actually a typical example that a lot of people online will show you, that this is how you would override the representation magic method. So basically, once this line is executed, what we get should be a printout that looks exactly like this line right here. So if I run this, now it's much more clear and easy to read, and it's understandable to the developer at least on what that is. Now the next set of magic methods that we're going to go over control how arithmetic operators behave when used on our objects. There are a lot of them, and while I am going to show a list of all the magic methods for all the arithmetic operators, I'm only going to demonstrate one in order to keep this video from getting too long. And the magic method that I'm going to demonstrate in this video will be for the addition operator, the plus sign. So the magic method for the plus operator for addition is underscore underscore add self, and then it takes one parameter. And we can pretty much call this anything we want. Some people just say other. Others name it after what the parameter is expected to be. And that's what I typically do. So I'm just going to call it M2, short for matrix 2, the matrix we're going to add to this matrix. And just to be clear, this magic method add only applies to the normal addition operator. It does not apply to the plus equals operator. So we're going to create a temporary matrix inside this method. We're going to call it temp. And we're just going to give it default values of 0 because they're all going to be overridden anyway, so there's no point in doing anything clever. And we can say temp.a equals self.a plus m2.a. And then we're going to say temp.b equals self.b plus m2.b. Just copy these. And so basically what we've done here is we've created a temporary matrix. We set all the default values, A, B, C, and D to 0. And then we basically go through and assign A, B, C, and D of temp with the normal integer addition result of the individual integers that were stored in A, B, C, and D for both self and M2. So now that we've got our temp matrix, all that's left to do is to return it, because all operators return a value and we need to have it return something. Otherwise, by default, it's just going to return none like pretty much any other function in Python. And we don't want that. We don't want to have a matrix A equals matrix B plus matrix C, and then all of a sudden matrix A is just equal to none because we forgot to return the temp matrix that we put in here. So we just say return temp. So now down here, we've got two matrices. We've got matrix A, which is 1, 2, 3, 4, and matrix B, which is just all fives. So when I create C here, I'm going to say C equals A plus B. And then we're going to print C, and with the help of our string magic method that's still there, we'll have it print out in a nice fashion. And so what we should get is a matrix that contains 6, 7, 8, 9. So 6, 7 on the first row, 8, 9 on the bottom row. So we're going to run the code. There you have it, 6, 7, 8, 9. And that's pretty much it. And like I said, here's a list of all the arithmetic operators and the magic methods that correspond to them. They all work the same way. They each take in a single parameter in addition to self, and then you just create a temporary variable. You perform the individual calculations that need to be calculated, have them stored in that temporary variable, and then just return the temporary variable. And that's pretty much it. Now, those magic methods only cover the normal arithmetic operations where you have a result variable and two operand variables, where it's like x equals a plus b. But what about the assignment arithmetic operators, the a plus equals b, or something like that? You know, what about those? They have magic methods as well. And again, like with the normal arithmetic operators, I'm just going to demonstrate one, but I'll show a list of all the assignment operator methods at the end of this demonstration. And so for this one, we're going to demonstrate the plus equals operator. So the magic method for the plus equals operator is IAdd. And like the regular addition magic method, it takes one parameter aside from self. So we're going to call the M2 as well. So we're going to still make a temp. Again, just default values with 0. And you know what? I'm just going to copy this to make it easier. So as you can see, it's pretty much the same. We're taking self and M2, adding their numbers together, and then storing them into the relevant variables in temp. It looks exactly the same as add. The only reason why we're doing this twice is because we want to account for the fact that someone might want to use the plus equals operator over the plus operator. So this is essentially the same. So A plus equals B, then print A. So we should get the exact same result as we did before when we added A and B together and stored it in C. So it should still be 6, 7 on the first row and 8, 9 on the second row. So run the program, 6, 7, 8, 9. And real quick, here's a list of all the assignment operators and their magic method counterparts. They all pretty much work the same way. And finally, what I probably find to be the most useful, the magic methods for conditional operators. But for this example, I've gone back to our pilot class, and I've got two pilots, one Crozo, that's a lieutenant, and one Titus, that is a captain. So these are the magic methods that are called when we use conditional operators. And for this example, I'm just going to demonstrate the less than operator. They all work the same way, so just by demonstrating this one operator, you kind of get an idea of how the others can be defined as well. So the less than operator is simply LT, self, and then we defined one pilot. We'll call it pilot 2. So for this example, I'm also going to create a table within the class itself. So we'll call it rank table. For LT, it'll be 0. And then we'll say captain will be 1. We're just going to keep it to just 2 of these. We're not going to make it too in depth or anything like that. So it's a bit wordy. I'll break down what it does. So since it's less than, if self is ever less than the one we're passing in as pilot 2, then it's got to return true. If it's greater than, then of course it would return false. And since this is just less than, that also includes if they're equal to each other. If they're equal to each other, then one is not less than the other, so it's still false. So what we're doing here is we're calling the class variable rank table, pilot.rank table, and we're passing in the rank of the first pilot into it because their ranks are the key to this table. So we pass that in here, and I just realized I typed captain not all uppercase, so let's fix that. So the first rank will be passed in here, and depending on which one it is, if it's LT or captain, it's going to return a value. So LT will say is the lowest ranking, so it gets the lowest number. And same here, pilot 2, we pass in his rank, and we get the numeric value. If they're both 0, it returns false. If the first one is 0 and the second one is 1, then it returns true. So I've got two pilots here, one that's an LT and one that's a captain. So if I say if A is less than B, print A.name has a lower rank than B.name. Else all right. So we got two pilots, we do a comparison, and for the first run, it's going to print out the first one because we're comparing an LT to a captain. So the LT is obviously going to be a lower rank than the captain. And then the second one, we'll flip the ranks around so that it should print out the second message. So we'll run it. Crozo has a lower rank than Titus. That's true. So we'll flip them around. And now it says Titus has a lower rank than Crozo. So that's how you would do that. And that's it for magic methods. There are a few other magic methods in Python, but I just wanted to focus on the ones that you had a much higher chance of actually modifying and using than others. There are quite a number of them that very rarely you would ever modify because their use would be so specific. And then for others, it's just there's really no reason to modify them, if at all. I could be totally wrong about that. There could be a reason to want to modify certain magic methods, but off the top of my head, I honestly couldn't tell you the reason for modifying a lot of them. It's best to just leave them as they are. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. If you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.